Welcome to the podcast. We are super excited today to have with us Q. Q, you just joined the ElastiCache team, right?
No, it's been a while.
While, let's qualify that.
Well, I joined AWS, and ElastiCache was my first team at AWS, and that was back at the end of 2012.
Wow. And ElastiCache was launched when?
It was around 2010, 2011.
Wow. So for almost 14 of the last 15 years or so of ElastiCache, you have been a part of the team.
Correct.
Was Memcached the only engine supported when you joined, or had we already started to support other engines?
Yeah, so Memcached was the bread and butter of ElastiCache when I joined. We didn't support Redis. Obviously, there was no Valkey.
Mm-hmm.
And a year after I joined, we have to make a decision on the roadmaps of ElastiCache and how it can evolve.
Mm-hmm.
So back then we have two choices. One is to continue to build upon Memcache, and the other one was to explore something entirely different, which is Redis, which was gaining lots of momentum at the time. And I was very glad that we picked the latter choice.
Yeah, I remember those discussions. I used to be in the cab at the time, and there was a lot of conversations around, hey, do we need to adopt Twin proxy? And do we need to make Memcache have a distributed system with replication and things like that? But I'm also glad that ElastiCache went in this particular direction.
Mhm.
It had the database services at Amazon at the time. I think ElastiCache was one of the first. I think it was just RDS and ElastiCache at first, right?
It was RDS and ElastiCache, and I remember DynamoDB as well.
Mm-hmm.
Yes.
Yeah. DynamoDB came out, and all of these database services had a Sesame Street inspired name. What was ElastiCache's name?
ElastiCache was Elmo.
Yeah, Dynamo was Big Bird. Eventually, when we launched Oscar and Grover, or which that's Aurora and the Aurora file system, or Oscar and Grover, and you see this in the code base, like at least on the Dynamo side, like our infrastructure, rack names, and a bunch of code packages had BB on them, and that just was short for Big Bird. Is that true for ElastiCache as well?
Yes, ElastiCache also, our internal code base names were usually prefixed with Elmo.
And so you've been working on helping EC2 and AWS customers accelerate access to their data.
Mhm.
You spent a lot of time on the Memcache side as well. I remember you spoke about Memcache at one of the Valkey meetups as well.
Yes, correct. Yeah, it's like another way to do caching aside from Redis and Valkey.
Hmm.
So I thought that was a very interesting topic to talk about, and so why not?
It was a great talk.
Yes.
The one thing that you've been talking to me about, and I really agree with, is so much of high performance access to data is about the server, but there's a lot on the client side
Mhm.
as well. So can you tell me a little bit about the emphasis your team has put on the client side drivers for Valkey, for instance?
Sure. Yeah, so basically over the years, what we realized with answering, thousands and thousands of customer questions for operations and for, incident responses or for best practices is that very oftentimes we have to dig into the client in
Hmm.
addition to looking at what's happening on the server. Was there a server event like recovery? What did the failover happen in the cluster, or was there a networking issue or something, right? So in addition to all the server problems, we also have to dive into the client side a
Hmm.
lot.
Hmm.
Like we usually ask a question like, hey, what client are you using? How are you connecting to ElastiCache server? What's your timeout settings, and how are you handling timeouts? And so over time we realize that there has to be some emphasis on client.
Hmm.
So because of that, we came up with a set of best practice guidances for
Okay.
customers on how to use Redis client or Valkey client later on, when Valkey became a thing. We started building our own client that implements a lot of those best practices.
Is that
Um,
Glide?
yes, correct. It's a Valkey Glide.
Hmm.
Yeah. It's like a multi-language. It has a multi-language bindings on top of a Rust core.
Oh,
So
wow.
so yes, it's meant to serve as a client that's flexible enough to support like most of the more important languages like Python, Java. Uh,
JavaScript.
yes, um, and .NET, for example, right?
Mhm.
So yeah, I think over time we started investing more into the client side.
It's also nice to have that single Rust core, I feel, because it lets you have consistent experience across the languages in terms of how you're engaging with the server, with your timeouts and retries and
Yes,
things like that.
correct. And also, like for Redis and Valkey, another very important thing is to discover your topology.
Oh
Say
yeah.
if you have a cluster with multiple nodes,
Uh-huh.
sometimes maybe a few hundred nodes, then which nodes are in the cluster, who are the primaries and who are the replicas, and if a failover happens, you have to make changes to the topology. All of that discovery logic can also be built into a common sort of library. Yes,
Yeah, and that's where that consistency really matters,
correct.
as
Yes.
well, I think. Let's talk about Java. A lot of your end users end up talking to databases over JDBC,
Mhm.
and then they inevitably realize that either the database is too slow or they're just putting too much load on it, and inevitably they end up adding ElastiCache or some form of cache associated with it. Any improvements on Spring or JDBC or things like that in the Java ecosystem that you're
Sure.
particularly excited about?
Yes, let me go back a little bit. So,
Yeah.
how this came up, right? Is obviously, there like lots of the customers are using relational databases. If you build a web application, relational database is probably the most essential component of your application. You may or may not necessarily need a cache, but you always need a database.
Hmm.
And JDBC so far, like based on all of my customer conversations, is probably the most popularly used
Hmm.
driver that people use to connect to a relational database. And very oftentimes, as the application scales, they would like to start adding a layer of caching to
Right.
speed up the queries, especially for the more expensive queries that take time to execute, and also it's very computationally intensive, right? Kind of takes resources away from the database, right? So very oftentimes people try to offload it into the cache.
Hmm.
Another problem that we heard from customers is it's very difficult for them to build this caching logic into the application.
Okay.
Yeah, where they have to basically do a lookup into the cache for the query that they're trying to run. If it's not in the cache, you go to the database, fetch it, put it into the cache. Next time, you read it from the cache. So all of that complexity.
That's probably the most popular 5 lines of code in the world, right? If in cache, return, otherwise go to database, put it in cache, and then return. That's gotta be everywhere.
That's very commonly, yes, very commonly put, it should be everywhere. But in reality, what we heard from customers is that sometimes, depending on the nature of the application, right, on the code base, it's not always easy to do it.
Yeah. There's
Because
so many knobs.
and also it's like if the code is very well structured in a way that all that logic is in one place,
Yeah.
it's easy. But if you're running 100 queries across 100 different places of the code,
Hmm.
doing that becomes a nightmare. It can take up to weeks. Basically, we sort of went and explored how we can make that experience better for the customers.
Okay.
And yeah, so that's,
So what did you do?
well, I mean, we looked into two different angles here. One is that if we can incorporate caching natively into the server side,
Hmm.
like for example, in the proxy layer, we can do transparent caching.
Yeah.
That's one approach that we explored. Like maybe 2 or 3 years ago, we started looking into it. And then the other approach would be to do something on the client driver,
Hmm.
right? Natively into the client driver,
Yeah.
where you get all this complexity of caching kind of wrapped away from the application developers. There are two different categories of customers. One category of customer is the DevOps folks, right?
Yeah.
They have an application that's already built. They just want to be able to run it reliably, accelerate the database, so they probably will prefer having a transparent experience where
Hmm.
caching is kind of
Built in.
built into the proxy layer somewhere where they just switch endpoint and it works. But when I talk to actual engineers,
Hmm.
when I talk to actual developers, they are talking about the driver itself.
Okay.
They are, because they are very intimately involved in building the application, and they know exactly what query that they're running. They know which queries are expensive, which queries are doing full table scans that takes a lot of time and computational resources in a database, and so they are typically talking about building it into the application and on the client side. And last year, I was involved in addressing that pain by incorporating caching into our AWS JDBC client wrapper.
You define two categories, the software developers and the site reliability engineers. And I'm curious, this should be appealing to both, I would imagine. So I'm trying to figure out the categorization there.
I believe this is appealing to both, but the solution that we built into the client driver is probably more appealing to the developers, because that solution is obviously very simple. You no longer have to implement the core logic to do look-aside caching, right? But you still need to make some code change in the application to enable that caching feature in the AWS JDBC client driver. It's like a plugin that's disabled by default.
I see. So now let's say you opt in. Once you opt in, this is enabled for basically all users of that JDBC client in your
It can
JVM?
be, but then yes, it's not just about enabling the plugin in general, but you also have to be very specific in terms of which queries.
So I can opt in on a per query level as opposed to a per connection level?
Correct.
Okay, that's important, right? Because I don't want to inadvertently opt in for sale data, for instance.
Correct. Yes. There are certain queries which are not very good candidates for caching.
Okay.
For example, if you are doing highly transactional workloads on the table where there's like millions of updates every day, and you need to read data live, right? Like a ticket sale, then you don't want the data to be cached away with a TTL, and then you're reading data from say 5 minutes ago, or right? You need the data to be fresh. So for those categories of our applications, then probably caching is not ideal, right? It's not necessarily the best idea. But there's also another category of queries where you are reading data from the database, which is not frequently changing. Inventory items in a database, right? So those data, sometimes you are querying in a very huge table. And it's expensive to run the query. But the data almost never changes, or rarely changes, or doesn't change frequent enough for it to really matter. So then in those cases, I think it's a good idea to put it into the cache so that, you don't have to hit the database every single time.
When I'm opting in for a particular query to enable this cache, do I get to tell you my TTL?
Yes. So the way it works is that when you opt in per query, you have to prefix your query with a query hint.
Okay.
In the relational database world, query hint is a very common technique, right? It's been around forever. So you prefix your query with a query hint that tells me what is the TTL you want to cache this result with.
Great.
So and the way that you determine the TTL would depend on how often this data is changing, right? So if you expect, say, the inventory table to not change, and if it changes maybe a few times a day, then you can cache with a very long TTL of hours maybe. But if your table has more transactions per day, then you can cache it with a shorter TTL, maybe minutes instead of hours.
I would argue it's less to do with how often the data is changing and more to do with how much staleness you're willing to tolerate. Those are slightly different things, right? Because let's say a counter is changing a million times a second, but I just want to show you up to the second data. Like, it's okay if it changes a lot, because I know that it's also going to change on the way back to you. But how do I size the cache? If that's not going to be done at the query time, I assume you have like a central configuration for the amount of RAM I'm willing to allocate.
Yeah, I think that actually brings up a very interesting topic for ElastiCache as well, because sizing the cache traditionally is on the customer. Right. I spin up, say, a Valkey server. I have to configure max memory, which basically dictates how much data I can have in the cache before it starts to evict old items. Right. I mean, assuming that if you're using like your eviction policy is configured to be LRU, then I will be using LRU and you'll try to evict old items. Right. Let's just say that. it's very challenging for people to size their cache, especially when your application suddenly start growing and you're having a hard time forecasting, like, okay, I would need, I need 1 gig of RAM right now, but a year later I need, maybe 10 gig of RAM, or
Yeah.
is it 10 gig or is it 100 gig? I have no idea, right? So, so in ElastiCache, what we have is something called serverless. Serverless meaning, you come to ElastiCache, create a serverless cluster, and we will do the sizing behind the scenes for you. So as your data usage goes up, we will expand. We will automatically expand the capacity of the cache, so then you don't have to worry about sizing your cache.
But what about on the JDBC driver node, like the web server on which I'm running this client-side caching on JDBC? Am I giving you a hint on, are you doing local caching here at all, or is it all going to a Valkey backend?
The JDBC driver caching feature that I built into the driver is a remote
Okay.
caching functionality. So
Okay,
I
got it.
basically will read the result from the database the first time, and then I will put the result into a remote Valkey server.
Got it.
So in that sense, you don't have to worry about sizing the cache on the client application side, right? Assuming that the server is configured appropriately for
Awesome.
how much data you really need. And with ElastiCache Serverless, that concern kind of goes away mostly because we will do the sizing for you.
Now,
Yes.
this particular JDBC driver change, does it only work with ElastiCache, or can anybody use it with their Valkey deployments?
It's an open source package. Like this driver essentially is an open source project on GitHub.
Okay.
Where we basically just wrap on top of the standard JDBC drivers for
Awesome.
Postgres, MariaDB, and MySQL.
Yeah.
And we basically build on top of the standard JDBC driver features, which are good for AWS. Like, for example, we have a plugin that handles automatic failover of the primary database. We have a separate plugin for blue-green deployment, if you have to upgrade your database to a newer version, right? For this caching plugin, it's also kind of fit into a similar category where everything is open source. You can literally go and spin up a Postgres server on your local machine, and then you can spin up a Valkey server also on your local machine, and there's nothing in AWS. It's all just running on your
awesome.
application servers, and then you can just literally just get it going.
When did this driver come out?
Automatic query caching capability came out 2 weeks ago.
Okay.
At the end of March.
How's the response been? Are anybody deployed it yet? Have you heard any positive or negative feedback?
So far, I think it's still pretty new. It's still pretty fresh, right? We are trying to get the word out to more people.
Right.
I actually had talked to one particular customer in India, and they are very interested, and they started testing already.
Awesome.
We also have a couple of internal users in Amazon.
Nice.
Yeah.
This is pretty exciting. I can't wait to go try it myself. And I can't wait to go see more feedback on it. If you have feedback on this driver or on anything related to Valkey, you should join the Valkey Slack. You can come in, you can find Q on the Valkey Slack as well, and you can DM him your feedback directly. And you should come to Unlocked. It's on May 7th in Seattle at the T-Mobile Park. We will see you there. Thank you so much, Q, for joining the podcast
Thank
today.
you for having me.